In this video, we're going to look at dealing with 2 by 2 matrices. So that involves finding the determinant, the inverse, and also using the inverse in calculations. So just in general, I'm going to write a few generalized expressions here. When a 2 by 2 matrix is in the form A, B, C, D, we say that the determinant is given by AD minus BC. So that's 2 times 3 is 6, take away, minus 2 times 1, which is minus 2. Now 2 minus is joined to make a plus, so that's 6 plus 2, which is equal to 8. Now when you're finding the inverse of a matrix, again generally when it's in the form A, B, C, D, then we say it's 1 over AD minus BC. And then you swap the positions of D and A, and you multiply B and C by minus 1. So applying that same concept here, we can say it's 1 over AD minus BC, which we've already found is 8. So you can say essentially it's 1 over the determinant. And then inside of the matrix, you swap the positions of 2 and 3, so it becomes 3 and 2. And then you multiply both of these by minus 1. Minus 2 times minus 1 is positive 2. And 1 times minus 1 is minus 1. Sorry about that. You can then multiply everything inside the matrix by an 8. So 3 times an 8 is 3 eighths. 2 times an 8 is 2 eighths, or 1 quarter. An 8 times minus 1 is minus 1 over 8. And lastly, an 8 times 2 is 2 over 8, which is 1 over 4. And that's everything for part B of the question. Moving on to part C, it says solve the equation AXY equals this expression here. So we're trying to solve it for xy. If we apply the inverse of a to both sides, that will cancel out the a on the left hand side and get you to the fact that xy can be given by finding the inverse of a, which is what we've already formed here. So let's write that matrix out. 3 eighths, 1 quarter. You can write out this format as well if you prefer, by the way. Let's do it that format actually. So we have an eighth of 3, 2, minus 1, 2, all multiplied by the matrix that's already there. That's minus 1, 2. Now we're going to leave an eighth outside because we're going to multiply that to every individual term afterwards. So 3 times minus 1 is minus 3. And then 2 times 2 is 4. Minus 3 plus 4 is positive 1. Minus 1 times minus 1 is 1. 2 times 2 is 4. 1 plus 4 is 5. So that can be written as, 1 eighth times 1 is 1 eighth, and then 5 eighths. Perfect. Let's now move on to part D. Write down the matrix B such that this equation is held true. But once again, we can apply the inverse of A to both sides, and we get that the matrix B is given by the inverse of A multiplied by 4i. So let's multiply those together. So for the inverse of A, once again, I'm going to write out this expression here. So 1 eighth, lots of everything that was already there. 3, 2, minus 1, and 2. That's just what we found in part B. But I didn't bother writing out this format because dealing with fractions tends to be more difficult for students. And then we're multiplying onto that 4i, which is 4 times the identity matrix. Now we are dealing with a 2 by 2 matrix here, so it's 4, 0, 0, 4. After you've multiplied 4 into each term. Now, again, I'm going to leave the eighth outside the bracket. 3 times 4 is 12, plus 2 times 0 is 0, so that's just 12. Minus 1 times 4 is minus 4, and then 2 times 0 is 0, so that's fine. 3 times 0 is 0, 2 times 4 is 8. Minus 1 times 0 is 0, 2 times 4 is 8. Lastly, we just multiply everything inside of the matrix by an 8. 12 over 8 is 4 over 3 as a fraction, so let's write that out. 8 times an 8 is 1. Minus 4 times an 8 is minus 4 over 8, which is minus 1 over 2. And then an 8 times 8 is just 1. And so this is the final answer for the matrix of B. That's everything for this question. Be sure to leave a like if the video helped and subscribe. This was just a basic recap of pretty much a lot of the fundamentals you need to know about 2 by 2 matrices. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.